Okay, very good. Okay, so yesterday we talked about the polynomial inequalities, right? So a polynomial inequality is like an inequality like this: x cubed plus x is less than 0. So whenever you have a polynomial inequality, what is the first step you do? You remember?
Find the root.
Find the root.
Right?
Yeah.
The first step.
Before, yeah, exactly. So that means you have to factorize. Exactly. First, you have to factorize as much as you can the polynomial. Like, for example, x cubed minus x, I can factorize it as x times x squared minus 1, and then x squared minus 1 is x minus 1 times x plus 1. So the factorization of x cubed minus x would be x times x minus 1 times x plus 1. That is the factorization, right? And then once we factorize, yes, then we can find the root of or roots of each factor. Okay, so the ideal thing is to factorize a polynomial into first order and second order factors, right? If you have something like x cubed plus x, then you can factorize it as x times x squared plus 1. But here you see x squared plus 1 because it doesn't have any root, so you cannot factorize it further. So you cannot factorize x squared plus 1 into first order terms. Okay.
So we just leave it there.
Yes, exactly. So you have to leave it there because it doesn't have any roots. So whenever you have a second order factor that doesn't have any root, you leave it there, and we know it's either always positive or it's either always negative, because it doesn't have any root. It doesn't cross the x-axis. So it's either always above the x-axis or it's below the x-axis. And it depends on the coefficient of this x squared. If the coefficient of x squared is positive, it's always positive. If the coefficient of x squared is negative, it is always negative, right? So just give you some quick example of a second order term that doesn't have any root. So just recall the quadratic. So if you have a second, like say minus 2x squared plus 3x, and then minus 4, right? If you have something like this, remember the quadratic formula. The quadratic formula says if you want to find the roots, then there was a, like we call it discriminant, or we usually use delta, which is basically b squared minus 4 times a times c, where b is the coefficient of x. So that is b, that is c, and that is a. So what is delta? It's 9 minus what?
4 times -2 times -c, positive then. 8, then -13, 32.
So 4 times AC is 32. 4 times A times C, because it's 8 times 4 is 32, right?
Yeah.
So it's 9 minus 32, which is equal to minus what?
Minus what? Minus negative 20, 21, 23, 23.
23, yeah. But you know, this is a negative number. So when the discriminator is a negative or
roots.
delta is negative, so there is no,
Root.
so delta is negative. So there is no roots. Okay. And because there is no roots, this guy has to be always positive or negative. Now you look at the coefficient of x squared. Is the coefficient of, what is the coefficient of x squared?
-2.
-2, it is negative. So minus 2 squared minus times 2x squared plus 3x minus 4, it's always negative.
Huh? So I can determine is less than 0 by the coefficient.
Hmm?
Why? Why is always negative?
Okay,
Because the coefficient is -2.
yeah. So it's always the same sign. If the coefficient is positive, it's positive. If the coefficient is negative, it's negative. Mm-hmm. I mean, you can even, I mean, let me, yeah, just let me tell you why it's always negative. Oh, I mean, first of all, from the geometric point of view, whenever you have a, just to give a geometric argument, whenever you have a quadratic that doesn't cross the x-axis, so it should be either always like this or this, right? Doesn't cross the x-axis, right?
Yeah.
So I mean, this is just a simple argument because it's either always above x-axis or below the x-axis. So, and it's a parabola. So it can, so it's always positive or always negative. Now, whether it's positive or negative depends on the sign of A. And why it is that? Because you can see, so let's look at this example, for example. The example I gave you is -2 times x squared plus 3x minus 4. This is equal, if you factorize -2, it's -2 times x squared minus 3x plus 2, minus 3 over 2x, sorry, plus 2, right?
Yes.
Now, if you take another step, it's x squared. Now, x squared minus 3/2 x plus 2, you can write it as x minus 3/2 square, sorry, 3 over 4, not 3/2. Three over 4 square. Now x minus 3 over 4 square is x square minus 3/2 x plus 9 over 16. Now you have to subtract minus 9 over 16, right?
Plus 2.
Plus 2, exactly. Now that is equal to minus 2 times x minus 3 over 4 squared. Now what is 2 minus 9 over 16? So 2 minus 9 over 16 is 32 minus 9. What is 32 minus 9?
23.
Yeah, so it's plus 23 over 16. Okay. So
Yes.
now we get something good. Now we can draw a picture because
The vertex form.
yeah, it's a vertex formula, exactly. So because you know that x minus 3 over 4 squared plus 23 plus 23 over 16 is something that looks like this. If this is like, imagine that this is the point 3 over 4. And that you have another point, which is 23. Imagine this is 23 over 16. And that is the vertex, right? So, I mean, if you just neglect minus 2, if you just neglect minus 2, it would be something like this without minus 2. Right? I mean, just ignoring minus 2, then you have this picture. Now, when you multiply it by minus 2, when you multiply it by negative 1, you have to flip the shape. So multiplying by negative 1, you have to flip the shape. And when you're multiplying by negative 2, you basically have to also stretch it along the y-axis. So it goes like this, something like this. So this would be y equal to minus 2 times x minus 3 over 4 squared plus 23 over 60. So you say it's always below the y-axis. It's always negative. Okay. So far, so good?
Mm-hmm.
Okay. Now, pardon me?
I'm not continue.
Okay. Did you have any question, Alan?
What question? I don't know. I know how to draw it. You first convert it into vertex form and you draw out the vertex. And then, yeah, you use the first coefficient as negative. And then,
So we can, if you are today in the school, we can talk about it, okay?
okay.
Okay. Just please come and we will discuss it. I mean, any of you. If you have questions, please come and talk to me. Okay. Now, the next is, so another thing that I wanted to review is that we have also rational inequalities. So remember that we have rational functions. Rational functions. What is a rational function? A rational function is a division or a fraction of two polynomials. Like so you have a fraction with two polynomials on the top and the bottom, okay? Now, so these are rational functions. So you can have also rational inequalities. So rational inequality, it's like the questions that you have in your assignments. Let me look at the question. Yeah. For example, so in one of the assignment, you had something like square root of 1 minus x over x plus 2, right? That was a function f of x. And they ask you to find the domain. So in order to find the domain, we know because the existence of the square root, there should be some restriction for the square root. What is the restriction for the square root? What is the restriction for the square root? Whenever you have
the entire function inside the square root cannot be less than 0.
Yeah. So
greater than 0.
Yeah, that inside the square root, it should be greater than or equal to 0.
Yes.
So 1 minus x over x plus 2 has to be greater than or equal to 0 because of the square root. That's the square root basically restriction. Now you look at this. This is a rational inequality because you have a rational function and you have an inequality. That's why it's called a rational inequality. And to solve a rational inequality, you have to do the same thing as we did for polynomial. So first you have to factorize the denominator and the numerator. So the first step is to factorize both numerator and denominator. Okay. But here the good thing about this function is that it's already factorized because you have only, or on the top you only have one term, 1 minus x, with a linear first order term. At the bottom also you have a first order term. So it's already factorized. Then so 1 minus x over x plus 2.
I think f's restriction is from -2 to 1.
Yeah, so let me just, yeah, that's right. So next step, second step is to find the roots. Finding the roots of denominator and numerator, or I just put finding the roots. That means finding the roots of both numerator and denominator. Okay.
Mm-hmm.
And here it's easy because for this question, the roots are x equal to 1 and x equal to -2. Then finally, the last step is just draw a table. To determine the sign of each term, and finally to determine the sign of the whole expression. So when you draw a table, you first put the first row, the roots goes to the first row. So you have to put them in order. So you have -2, and then you have 1. And then you put each of the factors, like 1 minus x, and then x plus 2. Okay.
Mhm.
And then you have the whole thing. 1 minus x over x plus 2. So when x equal to 1, 1 minus x is 0. When x is greater than 1, 1 minus x is negative. When x is less than 1, 1 minus x would be positive. Now if we look at x plus 2. When x is -2, x plus 2 is 0. When x is greater than -2, x plus 2 is positive. And when x is less than -2, x plus 2 would be negative.
And we
So
cannot get negative.
that's this, pardon? Too?
We cannot get negative here, right? The function.
Yeah. So now we look at the whole expression. The sign is just the product of the signs. So plus times minus is minus, plus times plus is plus, and minus times plus is minus. But you have to be careful because x plus 2 is 0 when x is -2, and x plus 2 is at the denominator. We also have a restriction for denominator. Denominator can't be 0. So the whole thing doesn't exist. I just put DE when x is equal to -2. So that means x equal to -2 is not in the domain because of the denominator restriction. But when x equal to 1, there is no problem because the whole thing would be 0. Now you're looking for the region when this expression 1 minus x over x plus 2 is greater than or equal to 0. And where is the region? I mean, the answer would be this neighborhood or this region, right? So that means x has to be less than or equal to 1 and greater than 2. Does it make sense?
Yeah.
Okay. That's it. So that's basically, we solve a rational inequality in order to find the domain of a function that involves square root, basically, and also a rational function. Okay. Do you have any question about these rational inequalities or polynomial inequalities?
No.
Now, I want to begin the topic, a new topic, which is exponential functions. So these are a new type of functions, an important type of functions that you learn in advanced functions and in general in calculus. What is an exponential function? An exponential function is a function like f of x equal to, for example, 2 to the power x. So the x, so here is the key point. The x, which is the free variable that we use to define this function, goes to the exponent. So the variable goes to the exponent. And there is a substantial difference between 2 to the power x and a function like, I just put g of x, like x squared. Because the function x squared, the variable is not on the exponent. Exponent is 2, is fixed, it is constant, it doesn't change. But the base here is x. The base changes. But for the first one, which is an exponential function, exponent is not fixed. The exponent can change, right?
Mhm.
So that's a substantial difference between exponential functions and a polynomial. Or you can have like 3 to the power x. And the most important one is e to the power x. And I will tell you about what this e is a number. It is an irrational number. I will tell you more about this, what this number is, and what it represents basically. But these are all examples of exponential functions. So before going through the exponential functions, I just want to make sure you know some basics about working with exponents. So this is, say, some review of exponents. So there are some rules like the product rule or the power of a power or the division of two exponents and so on, which I'm going to write down. So the first rule is the product of two exponents like x to the power a or times x to the power b, which is equal to what?
xab to the
A
power
plus,
ab.
no, a plus.
A plus, yeah.
However, if you had something like x to the power a, then to the power b, that is a power of a power. So then would be equal to x to the power a times b. Okay. For example, 5 squared to the power 3, this would be 5 to the power 6. Now, when you divide two exponents, like, or two powers, like x to the power a divided by x to the power b, then this would be x to the power what?
X a minus b.
X to the power a minus. Then something important you can see even here, that whenever you have a negative exponent like x to the power negative n, that would be 1 over x to the power n. We also have the roots, like a root n. So the root n of something, you can write it as an exponent, which is x to the power 1 over n. So that means if you have another exponent inside the root, so we call the nth root, like the second root, third root, and so on. Or the square root sometimes for the second root. So if you have x to the power n, then the n root then would be x to the power, can you write it as an exponent? Inside is m. This would be x to the power m to the power 1 over n, right?
Yeah.
Which is equal to x to the power m over
M
n.
over
n. Yeah.
For example, x, the cubic root of x to the power 4 would be equal to x to the power 4 over 3. Or if you have something like 1 over square root of x, you can also say that because a square root of x is x to the power 1 over 2, you can also say this is equal to x to the power negative 1/2. So 1 over square root of x is x to the power negative 1/2, if you want to write it as exponent. So another rule is that when you have multiplication of 2 or 3 more exponent, like x to the power a times y to the power b, the whole thing to the power c, then this would be x to the power a times c times y to the power b times c. For example, x squared y to the power 1 over 3 is equal to x to the power 2 over 3 times y to the power 1. Okay?
Mm-hmm.
Now, let's go and look at, so these are just some facts that you should know about the exponents, working with exponents. Make sure you know and you understand each of them very well.
Mm-hmm.
And please let me know whenever you have any questions.
Mm-hmm.
Okay, now let's go and look at the exponential functions. So I told you that functions like f of x equal to 2 to the power x or 3 to the power x. The base can be any positive real number, like 1/2 to the power x. It can also be an irrational number, like a square root to the power x.
What about negative number?
No, we don't put negative numbers.
Okay.
We don't put negative numbers.
Mm-hmm.
Okay.
Mm-hmm.
So just let's pick one of them. I mean, the simplest one would be 2 to the power x. Actually, the simplest one would be 1 to the power x. Let me tell you this, because it's important. Although it's somehow trivial, but because 1 to the any power would be 1, this is simple but not interesting, because it's always constant. So 1 to the power x is just a constant function, which is 1. Okay.
Mhm.
So, yeah. So let's look at another one, which is more interesting, 2 to the power x. And let's look at some values of this function. So say this is x. I just draw a table, and that is f of x. So what happens if x is 0? What is 2 to the power 0?
1.
1, yes. So remember that if you have any number like a, you take exponent, if the power is 0, a to the power 0 is just 1. So any number to the power 0 is 1. Okay. What if x is 1? Then f of x would be
2.
2. What about 2? X equal to 2.
4.
4. What about minus 1?
1 over 2.
1 over 2. So you see, something that you can observe here is that when x is a negative number, like, and it's close to negative infinity, like negative 10, negative 100, what would be the value of f of x? What happens if x is negative 10, for example? Then f of x would be 2 to the power negative 10. 2 to the power negative 10 is 1 over 2 to the power 10, right?
Yeah.
And 1 over 2 to the power 10 is 1 over 1000 and something. So it's a very small number, right? So I just put minus 2. If x is minus 2, then 2 to the power x is 1 over 4. If x is minus 3, then you get 1 over 8, right? So you can see from here, first of all, when the value of x increases, then the value of f rapidly increases. I mean, it increases like dramatically. Like it goes like from 2, 4, 8, 16. It gets doubled each time. And on the other hand, if x is like a very small number, I mean, like a negative, like negative 10, negative 100, then f of x would be close to 0. Right? So we say that when x goes to negative infinity, then f of x, which is just 2 to the power x, goes to 0. And you can draw a graph, the graph of this function.
Teacher?
Yes.
How can this symbol express from which, I mean, like, you can also be close to 0 from opposite side or negative side?
Okay, that's a very good question. That's a very good question. So 2 to the power x is always a positive number, no matter what x is.
Yeah, but how should I express this by symbol? Only this area?
Yeah. Symbolically, we just say the limit is 0. Yeah.
Oh,
Yeah. We don't
okay.
put like 0 plus or minus. But what we know, and it is important to know, is that this guy is always positive. So
Okay.
2 to the power x, 3 to the power x, e to the power x, these are all positive functions. They are always positive.
Mm.
And the value of this at 0 is 1. So the y-intercept would be 1. And we saw that when x approaches negative infinity, then f goes to 0. F of x approaches 0. So it looks something like this. But the increase in the y value when x is a positive number is very rapid. Okay.
Mm-hmm.
So this was just exponential function. You can have also exponential inequality, equality or equations. So one might ask you, for example, you have this function 4 to the power x, and let me just ask you some simple question. What would be x if 4 to the power x is 16?
2.
X is equal to 2. I mean, another way to get this solution is you can write 4 as 2 to the power x, right? So we can say that 2 squared. So 4 is 2 squared. So we can say that 2 squared to the power x is equal to 16. But we know that 16 is 2 to the power 4, okay?
Mm-hmm.
Now 2 squared to the power x is 2 to the power 2x. So 2 to the power 2x is 2 to the power 4. So that means 2x would be equal to 2. That is 2x is equal to 4. That means x would be 2. Now, if you had an equation like 4 to the power x equal to 8, then what would you do? Try to write the left-hand side in terms of 2. Again, because you have 4 is 2 squared, then you have 2 squared to the power x is equal to, what is 8 in terms of exponents of 2?
Here is 3. So it would
2 to
be
the power 3. So
3
that
over 2.
means 2 to the power 2x is equal to 2 to the power 3. So what is x?
And 3 over 2.
And you can see and try that this is actually a solution, because 4, just plug in and try. 4 to the power 3 over 2 is equal to, if you do, I mean, you can do this in many ways, but one way is just to write 4 as 2 squared times 3 over 2. So this is equal to 2 to the power 2 times 3/2, which is 2 cubed, which is 8. Okay, any question?
No.
Now, the next topic that maybe I will discuss it tomorrow is what is this number? What is the number E? And where it comes from? Okay,
Mhm.
so we will discuss this tomorrow.